Hey GED students, so there seems to be a theme in all the groups that I belong to lately. Everybody's working on inequalities and people are struggling. Like, what do I do when there's X's on both sides? So first of all, I'm titling this one Help, I'm Solving, and there are letters on both sides. So we can solve equations or inequalities, and the basic skill set is the same. So I don't want you to think this is only for inequalities. I'm going to do an equation first, an equation with an equal sign, and then I'm going to do an inequality, same basic skills for solving. We're going to look at what happens when there's letters on both sides. So first of all, just a really good general principle is to simplify before you solve in math. To do any math that you can do forwards on either the left-hand side or the right-hand side of an equation before you start moving backwards, before you start solving. But if you look at this particular equation that I'm looking at here, this first example, there isn't any work I can do on the left-hand side. So I'm totally ignoring the right-hand side of the equation right now and just examining the left by itself. There's two things going on here, sorry. There's a 3 multiplying with an m, but I don't know what that is. What's 3 times m? Who knows? Because I don't know what m is. And there's also a 3m adding with a 4. But similarly, I can't do this addition. Those aren't like terms. I can't add m's with plain old numbers. Again, I can't do the addition. I can't do the multiplication. There's no simplifying I can do on the left-hand side. And if you look at it, same goes for the right-hand side. So let's ignore it over here this time and just look at the right-hand side of the equation, 5m minus 16. Same problem. Who the heck knows what 5 times m is? I don't, because I don't know what m is. And who the heck knows what 5m minus 16 is? Same thing goes. I can't do this subtraction, again, because of this unknown m. So I'm kind of in a pickle. I can't simplify. So it is time to start solving. But these are my 3 basic wisdom principles for most linear equations. Now, these are wisdom principles, guys. A good order to try attacking things. It doesn't mean it is a hard and fast always rule, okay? After simplifying, that is always when I say get the letter to the same side. Now we're going to look at, right after I give you these basic wisdom principles, we'll look at one on the next page where this kind of trips us up a little bit. But the next thing I would do after I tried simplifying is getting the letters to the same side. Notice that I have m's on both sides of my equal sign. How in the world could I ever isolate m? How could I get m alone if m is everywhere? Okay, solving is getting the letter alone on his side of the equal sign, and I just can't do it right now. So what I need to do is I need to pick a side for m. Now you might be saying, which side? Now some of your teachers will tell you it has to be the left side, but as it turns out, it doesn't really matter too much with equations what side you're on. So I'm actually going to move this 3m over. Now, I've got a reason for that. The reason I want to move over the 3m is because I know that students make less mistakes when numbers stay positive. So notice this 3m here is separated from the 4 with an add sign, a plus sign. So this 3m, this whole thing is adding with 4. Now, I know a lot of students say, Kate, no, 3 and m are multiplying. Yes, 3 and m are multiplying, but I'm not taking 3 away from m. I'm taking that whole 3m away, and that whole 3m is a positive 3m. It's a term. I have to take it away by either adding or subtracting. In this case, subtracting. Now, the rule of solving is I can do whatever I want as long as I do it to both sides. So there I am taking 3m's away from both sides. So you might be saying, is that legal? That's totally legal. You can move letters too. Let's see what happens on this left-hand side. I'm going to erase my little circles here. If I do that. So let's look at my new equation now. So on the left-hand side now, I had a 3m, but I took that 3m away. It zeroed out. So what do I have? I have 0 plus 4, or just 4. Just the 4 is left, positive 4 or 4. And then let's see what happens on the right-hand side. Well, 5m minus 3m, I have 5 of something, like 5 apples, and I take away 3 of that same thing. I will have two of those things, in this case, 2 m's. And I haven't dealt with this minus 16 at all, so this minus 16 will still be there. Cool. And now I solved that problem that you were so stressed out about, having m's on both sides. Now my m is on one side. It happens to be on the right. It wouldn't matter if you'd have moved it the other way, okay? You'd get the same answer. But I have an m over there. So now I'm going to work on getting all the numbers that are over there with m away. And we've talked about this before, but when you're solving, you work GEMMA, you work the order of operations backwards. So we're going to solve. And we're going to work our order of operations, whether you remember it as GEMMA or PEMDAS, okay? You're still working it backwards when you solve. So you're going to move anything that's adding or subtracting first. So I see that this 16 is subtracting with my m, and so I will move it first. I'm going to do the opposite. I'm going to add 16. Now, once again, when solving, you can do whatever you want as long as you do it to both sides. So I'm going to do the same thing to the other side. And let's see what my equation will look like after this change. Well, on the left-hand side, I've got 4 plus 16. That gives me 20. This is an equation. Keep your equal sign. On the right-hand side, the minusing 16 and the adding 16 are opposite, so they canceled, but I still have that 2m dropping. And I'm still not done because my letter's not alone. Let's go ahead and let's solve for m by getting rid of this 2 that's hanging out. So what is that 2 doing right now? That 2 is all shoved up against m, so that 2 is multiplying. Let's go ahead and divide him away. And the rule of solving is we can do whatever we want as long as we do it to both sides. So I'm going to jump across the equal sign. I'll divide by 2 there as well. And let's see what our new equation now is after this change we've made. Well, 20 divided by 2 is 10. And on this side, dividing by, or multiplying by 2 and dividing by 2 cancels, so my m is alone. And so I just figured out that 10 is m. Now I could rewrite that as m is 10, m equals 10. Same difference. Those two things mean the exact same thing. And there we go. We've solved that equation that had the letters on both sides. So again, this is the basic wisdom principle that we could try attacking most linear equations. First, simplifying the left and right hand side. And I'm sorry, this goes for linear equations and inequalities, which is most of the solving on your GED. Then we get the letter to the same side, if that is necessary. And then finally we can solve. Okay, great. So now let's look at those inequalities that students have been sending me or posting about. I've seen 3 in the last 3 days. Here they are in order from simplest to most challenging. So let's look at the example here on the right-hand side of this page. Pretty simple. Inequality this time instead of an equation. I see 6x is less than 5x plus 2. Once again, even if I tried to follow this wisdom principle of simplifying first, there's no work to do. If you look at the left-hand side, all that is 6 times x, and I don't know what x is, so I can't make that any simpler than it already is. Same thing on the right-hand side. I can't multiply together 5 and x again because I don't know what x is. All I can do is leave them like that. And I can't add a 2 to something I don't even know what it's worth, and so I just leave it be. But I can get the letters to the same side. Now here's where I say on an equation, I didn't really care if you took it right or left. On an inequality, the wisdom principle does say get the letters to the left. If you take those letters over to the left, you're going to be more easily able to understand your answers and graph them, okay? And so I am going to move this 5x over, okay? I'm going to take that 5x away from the right-hand side. He's positive right now. I'm going to subtract him out. And I can do whatever I want, literally whatever I want when solving, as long as I do it to both sides of, in this case, the inequality. So both sides of the equation or the inequality. And you know, I ought to be consistent. I've been doing my balance change with a different color. Let's stay consistent. So subtracting 5x on both sides. Now let's see what my inequality looks like now. Well, if I had 6 x's, and I took away 5 of them. I had 6 x's. That's literally what that means. And I took away 5 of them. 1, 2, 3, 4, 5 x's are gone. Well, I'm just going to have 1 x left, a single solitary x. And I'm too lazy to write 1 x when I know that that's just 1 x. I just write x as a mathematician. Now I haven't done anything to change the inequality symbol or affect it whatsoever. There's only one thing you can do to affect an inequality symbol, that is to multiply or divide by a negative, to negate it. And I didn't do that. I subtracted. And so I'm safe. Now, 5x minus 5x, of course, zeroes out. It's gone. And what do I have left? I have 2 left. And this is a very simple inequality. X is less than 2. Remember what that means, though. That means that any number less than 2 makes this thing true. So 1 is less than 2. 1 would work. So 0. So's negative 43. So's 1/2. A lot of numbers are less than 2. And so very often, teachers will graph solutions on a number line for an inequality. It would look like this if they did. They would make sure that at least 2 was on the number line. If x is less than 2, that means it's not okay for it to be 2. So I'm going to use an open dot. 2 is not okay. But I'm going to color in the number line to the left because everything going out to the left is less than 2. That's the less than direction. And that's why I say these things are easier if you have the letter on the left, because I can see that x is less than 2 when it's like that. See how the arrow points left? Looks a lot like that arrow on the number line, and you can see I color off to the left. Okay, great. So there's the solution in like mathematical writing, and there's the solution on a number line. 2 different ways to see the solution to this inequality. Okay, great. Let's go look at the next 2, which get a little trickier. Next one, I see solve. So again, directions are solve, which means I do want to get the letter by itself, okay? And those 3 basic wisdom principles for linear equations. And you might be saying, Kate, what the heck is a linear equation? Basically, everything you see on the GED is a linear, unless it's a quadratic. Unless it has a little floating 2 on the x, it's going to be a linear. I don't have any little floating 2s on my x. This guy is a linear. Okay, so for anything you see of that nature, we said our first step would be to simplify the left and right-hand side. Again, basic wisdom principles, basic. Then 2, get the letters to the same side. And we said we'd go ahead and do that to the left when it was an inequality. It'd make our lives easier just because it makes our lives easier, not because it's not because it's bad the other way, okay? So we'll get the letters to the left. And then finally, we'll get the letter alone. We'll solve, we'll isolate the variable. Okay, let's give this a try. So first I said I wanted to simplify the left and right-hand side. Well, look at this left-hand side. I just see x minus 6. Once again, I can't take 6 away from an unknown number. I'm just going to leave it be. But the right does have some simplifying I can do. Notice, I can't add x and 2. I don't know what that is. But I can do the implied multiplication here. This problem says take 2 and multiply by this whole group of numbers, everything in this parentheses. I can do that. It's known as the distributive property. And if you've never done that before, you need to go watch a video on just that because it's so important to the GED. But basically, multiplication passes out over parentheses. 2 times x is 2x. And if you add 2 times, or 2 times positive 2, you're going to end up with positive 4. You're going to end up adding 4. Okay, wonderful. So I simplified this time. This time I did have some work I could do on the right-hand side at least. Now my simplifying's done. There's no work to do on the left. There's no work to do on the right. It's time to get all the letters, and we're going to go to the left since we have an inequality, okay? Again, not the only way to do this, just a wise way to do this. So I want this 2x to be gone, not just the 2, the whole 2x. So I got to subtract out the whole 2x. That's a term. That's a thing that's adding or subtracting. Okay, now I can do whatever I want as long as I do it to both sides, so I'm going to do it over there as well. Now, oh man, I was doing my balance change in a different color, and I keep forgetting. There we go. The change I'm making to both sides of my inequality. And again, as long as you make the same change to both sides, you're fine. Okay, so I had an x, and then I took away 2 x's. I took away more than I had. I'm going to end up in debt by an x. Now, if you struggle with that, you could have done that in your TI by saying, well, that's just 1x, and you could have done the 1 minus 2 part in your TI, and it would tell you that that's negative 1x or just negative x. Okay. Now, I haven't done anything to the 6, so it's still going to be there, minus 6. I haven't done anything that would change the inequality sign. 2x, take away 2x is nothing. Those x's are gone, and all I'm left with is a positive 4, a 4. Now, I've gotten the letters to the left. It's time to isolate the variable, get the letters alone. Now, remember, we said that we should move anything that's adding or subtracting first, since we work our order of operations backwards when we're solving. Backwards when we're solving. So start with anything adding or subtracting. So I will, pardon me, I will do the opposite of subtracting 6. I will add 6 to both sides. You always do the opposite when you want things to go away. So let's take a look at what our new inequality will be. Well, on the left-hand side, subtracting 6 and adding 6 will cancel, so that my negative x is alone. And on the right-hand side, there's some math to do. 4 plus 6 is 10. Now I'm almost done, but careful, the letter is not alone. There is still that little negative sign hanging out. And you might be thinking, well, what's that negative about? Well, remember we said that was the same as negative 1x. I'm just a lazy mathematician who doesn't write a 1 as a coefficient, a 1 as a number out front, because it doesn't matter. It's simpler to write it without the 1. But that's what it means. It means that x is being multiplied by negative 1. And so the opposite of that is to divide by negative 1. Now that's the balance change I'm making. Notice how I make it to both sides, but make a little note to yourself. Now's the time to really get this clear in your notes, because this is the most important part about solving inequalities. The only real difference between solving equations and solving inequalities is that when you multiply or divide by a negative, so I just divided by negative 1. When you multiply or divide by a negative number, not add or subtract now, when you multiply or divide by a negative number, what's going to end up happening? You negate both sides of the inequality. You are going to change the relationship. The relationship is going to flip. The side that was greater is going to be lesser, and the side that was lesser was going to be greater. And so you are going to need to flip the sign. Flip the inequality symbol. Okay, so let's see what our inequality will look like now. Multiplying by negative 1 and dividing by negative 1 cancel, so x is alone just like I want. Now, don't forget, this is the most important thing to remember. You just divided both sides by negative 1. You just negated the inequality. You just changed that relationship. That less than sign is going to flip and become a greater than sign. And then what is 10 divided by negative 1? Well, of course, it's negative 10. And I have a whole video on solving inequalities, a whole full-length class, if you need to do some more of that negating, flipping the inequality symbol. But for now, since we're just focused on letters on both sides of the inequality, I think I'm just going to stop there. So I get that statement. X is greater than a negative 10. Of course, if I wanted to slap that on a graph, I'd need to make sure that negative 10 showed up. Again, it's strictly greater than. I don't see that little equal sign underneath, so it's okay to be near negative 10 or greater than it, but not on it. So I'm going to do an open dot, and I'm going to put my arrow out in the greater than direction, getting larger and larger. And you can see that's the direction it was pointing when my letter was on the left. All right. Okay, great. Almost done. Now, for the doozy of a problem that I saw that made me want to make this video, okay? Are you guys ready? First step, don't panic. Okay, people see the fraction here and they want to vomit. They're like, oh my God, x minus 2 over 3, what am I going to do? We know our 3 basic principles are simplify, get the letter to one side, and then you can isolate the variable. But, you know, this fraction here is really just stressing most students out. So I'm just going to look at this. On the left-hand side, there's no simplifying to do. Once again, I can't do x minus 2. The whole thing's already dividing by 3. I don't know what that simplifies to. And then on this side, the 2x plus 11, there's no simplifying I can do, you know. And to get to the letter to one side, it would be really challenging right now. So the problem is I got to get rid of this fraction. So I'm going to teach you a trick. What you guys didn't realize was the day that you got two-sided math. So what do I mean by two-sided math? I mean like equations and inequalities where we have this relationship where I say the two sides are equal, or the two sides are less than each other, or the two sides. That day was a day we got a lot of power, guys. We got the power to literally do whatever we want as long as we do it to both sides, right? We have to keep the same relationship, but as long as we keep that relationship, we can do whatever we want. You can use that power to get rid of fractions. Let me show you what I mean. Think about what this fraction here means. This fraction here means that this entire expression, x minus 2, is dividing by 3. Well, that's what a fraction bar means, divide by 3. I could get rid of the bottom of that fraction by doing the opposite of divide by 3. What is the opposite of dividing by 3? It's multiplying by 3. Let's do that. I'm going to take the entire left-hand side and multiply by 3. Now notice, I need you to notice, or you're going to screw this up. I did not come down here and write times 3 underneath. And I got a reason for that. And that's because multiplication passes out to the entire left-hand side. You need to use parentheses so I know you're multiplying the entire left-hand side by 3. Fair enough? Okay, so the rule is I can do whatever I want to an equation as long as I do it to both sides. So you need to come over here to the right-hand side, take the entire right-hand side and multiply that by 3 as well. You might be saying, Kate, why am I doing this? It looks like it's going to make things uglier. Oh no, things are about to get better. Let's take a look at what happens when I multiply both sides by 3. On the left-hand side, multiplying by 3 and dividing by 3 cancel. My fraction's gone. That's just an x minus 2. Nice. Now, on the right-hand side, there's some math to do. I got this 3 that I need to pass out to everything on the right-hand side. I'm going to multiply everything there by 3. Again, that's that wonderful distributive property that says multiplication passes out to every term. So 3 times 2x would be 6x, and 3 times positive 11 would be positive 33, or plus 33. And now my problem just got a lot easier. That fraction isn't there anymore. Now that I got rid of the fraction, I can get the letters to one side. Again, since it's an inequality, I'm going to move the letters to the left. I'm going to take away this 6x. And I'm going to stay consistent. I'm going to use a different color. Okay. Now, the rule is I can do whatever I want when I'm solving as long as I do it to both sides. So jump across that equal sign. Notice how I write the minus 6x underneath the x. Why? Because x's can subtract with x's. I'm not going to write the minus 6x over here under the negative 2. They can't subtract. That wouldn't make sense. I line it up with my x so I make less errors. Okay, so I had an x, but then I got in debt. I started owing 6x's. It's like 1 minus 6. I'd get negative 5x's. Now I haven't touched the minus 2. That drops, and my greater than stays greater than. Okay, 6x minus 6x, that zeroes out. And so what's left on that right-hand side? Just a 33. And you can see I solved that problem of letters on both sides. Now it's time to isolate the variable. Okay, I've got to move that negative 2. I've got to move that negative 5 in order to get this letter alone. Okay, so again, we move anything that's adding or subtracting first. So the 2 is subtracting with x. I can tell because the minus sign is between the two of them. And so I'm going to add that 2. I'm going to do the opposite of subtracting 2. I'm going to add 2 to both sides. And you might wonder why I did that one first. Again, I'm working the order of operations backwards when I'm solving. Move anything that's adding or subtracting first. Okay, so on this left-hand side, subtracting 2 and adding 2 cancel so that I have negative 5x. And on the right-hand side, 33 plus 2 is 35. And I'm almost done. I got to get rid of this negative 5. Now, I got to tell you, 75% of students are going to try to do a lie here. 75% of students, let me pull out a red pen so you know this is a stupid thing to do. Don't do this. They're going to tell me, the opposite here is adding 5. No, not true. Not true. Why? Why? That 5 is not subtracting with that x. Now, I know what you're thinking. You're thinking, well, there's a minus sign in front, Kate. Yeah, there's a minus sign in front. But what is the 5 doing with the x? What's between them? See how there's nothing between the 5 and the x? They're all shoved together like that. They are multiplying. The opposite of multiplying is dividing. You need to divide by exactly the number you want to get rid of. I want to divide by negative 5. Now, again, the rule of solving is I can do whatever I want as long as I do it to both sides. So I jump across the right-hand side. I divide that side by 5 as well. And now let's see what my new inequality will be. Dividing or multiplying by negative 5 and dividing by negative 5 cancel so that my x is alone. Now I did the one thing that changes an inequality sign here. Remember we said if you multiply or divide by a negative, it will flip the inequality sign. I did it. So my inequality sign is going to flip. This one was a greater than. It's now going to be a less than. And there's the work to do. 35 divided by -5, not -5 now. 35 divided by -5. You can do it in your TI if you don't believe me, but that is -7. So x is less than -7. So there's the solution algebraically, but if they asked you to graph the solution on a number line, what would it look like? It would look like a number line where I had -7 going on somewhere. Okay, x is strictly less than -7, so I'm going to open it up with a open circle. It can't be equal to -7, just less than it. And then I'm going to graph off in the less than direction, and you can see my arrow points in the same direction that I graph off in. As long as my letter's on the left, that is. All right. Whew. We did some hard inequalities, and I took a while to do it. I really went slow this time because students were really struggling with this. But if you have any questions about this, be sure to drop them in the comments. But let me just, fair warning, if your question is, I don't understand distribution, you need to go back and watch the distribution class. We've got a full-length video on that. If your class is, well, I don't understand, let's see, what else did we do? Solving. I don't so good solving at all. Well, yeah, this is like the 12th lesson in my solving sequence because this is like as hard as solving gets. What was the last one? Or if you don't understand inequalities, again, we have full-length lessons on that, okay? So, but anyway, any other questions besides that, I'm happy to answer them and drop those in the comments.